Half a day students. Today we're going to be talking about percents. So first of all, we're just going to look at the word itself, percent. Looking at cent. Other words I could think of with the word cent are things like century, centipede, centimeter, cent, with regards to money. All of these words have something to do with the number 100. So the word percent, per in math we use for division, right? Like 4 miles per hour, right? 4 miles divided by 1 hour. So per 100. So 40%, in order to find the numerical equivalent, like a number without a percent, it's just going to be 40 per 100 divided by 100. You can use a calculator in order to find this, or use long division, or simply just move the decimal point 2 times to the left, which is equal to 0.4. We'll go over in the next slide some practicing for converting percents to decimals. Now we're going to look at this sentence. 8 is 40% of 20. So in this, we're comparing 8 to 20, right? So we can come up with this. We can say that 8 out of 20, so this part over our whole, this is our base number. 20 is going to be our base number. We'll put it on the bottom. Whenever you see the word of, that's your base number of 20. 20 is my base. So that part over a whole, 8 out of 20, is 40%, right? And we know percent just means over 100. So we can say it's 40 divided by 100. And this right here is a proportion, which we learned about in our last video. So we're actually going to use the knowledge of this proportion to come up with an algebraic model that we can use for all of the percent questions and problems in this section. And you can use it in real life too. Actually, this is probably the section that you'll use most often in your real life. Everyone deals with percents. You're going to be doing it when you deal with taxes, when you're just going to the store and there's 10% off sale, things like that. It's really important to know. So whenever we're dealing with percents, we're dealing with a number that's being compared to our base number, and our percent. And again, whenever you hear of a number, that's your base, okay? Percent is obviously the number in front of the percent. We want to take the numerical equivalent, and the number being compared is the other number that you're working with. If I was to call these A, B, and C, A, P, and B, I can actually set my algebraic model. We'll say that A, our number that's being compared to the base, is equal to the numerical equivalent of my percentage times my base number. We're going to be using this a lot in the following problems, but we'll just move on from here. So when we're converting to a percent to a decimal, the numerical equivalent, we're just dividing by 100, right? Percent just means division by 100. So you can either do 26 divided by 100 in your calculator, or like we said, move the decimal point. Decimal point. 2 spaces to the left. Okay. So if I have 26%, I know 26. If there's no decimal point, I know it's at the end, right? So if I was to move that 2 times, 1, 2, it would be in front of the 26. So we have 0.26. For 50, again, it's at the end. So we have 50 dot 1, 2. We have 0.5 or 0.50, but we usually will just use 0.5. 14.2, the decimal point is right there. I'll move it 2 times. 0.142. 7%. The decimal point's right after the 7. I'm going to move this 2 times. So watch this carefully. It's there. I need to put a 0 right there to fill that space. So it's going to be 0.07. 0.55, I'm moving it 2 times to the left. Okay, so 0.55, 1, 2. I got to fill in those 2 spaces. So we have 0.0055. 100%, same thing. Find your decimal, move it 2 times. 1.00. 160, this is over 100. So you're going to get a number that's bigger than 1. So move it 2 times. 1, 2. 1.6. This could just also be 1 over here. Sorry. There you go. So now that we're okay with finding the numerical equivalents, we can move on. So now we're going into finding percents or bases or unknowns, right? So number compared to a base is unknown. Again, we're going to use this same thing that we did before. A is P% of B, right? We have a number being compared to a base, a percent, and then our base. So A is P% of B, and that's going to give me A is equal to P times B. So using this, 30%, I know my percent, right? My P is actually going to be the numerical equivalent, which is 0.3. Right, moving it 2 times. And of 70 feet. So what is 30% of 70 feet? So if once I see this number of, I already know that's going to be my base. So 70 is my B. Okay, setting this up. A is unknown, so A is equal to P, which is 0.3, times B, which is 70. Multiplying these, I have 21. So A is equal to 21. So 21 feet, you'll want to use, when you have things that are dealing with units, you'll want to use the same units. So we can say 21 feet is 30% of 70 feet. Okay, now what is 150% of 200? So again, my percent's already very easily recognizable. P is equal to 1.5 now, right? Moving it 2 times to the left, I'm in with 1.5 of 200. I know already, see that of, that's my base. So what is 150% of 200? So again, my number that's being compared is unknown. So I'm going to say my A is equal to 1.5 times 200. Again, you can use your calculator or you can just do it in your head. Okay, 1.5 times 200 is 300. And since this is a word problem technically, because I'm dealing with units, right? I want to attach a unit to that. So I'll just say $300 is 150% of 200. And if you see something like this, it says 150%. I know it has to be more than 200 then, right? It's bigger. It's more than 100%. It better be higher than 200. $14 is 25% of what amount of money? So now this is a little bit different because my base number, this of, after the of is unknown. So I know my base number is missing. So I need to find my B is what? I don't know what B is, right? So I'm still using A equals P times B. Now my B is unknown. So $14 is going to be my A. So we have 14 is equal to 25%. Numerical equivalent is 0.25 times B. Now in order to solve for B, I'll just divide by 0.25. And please be careful when you put something like this in your calculator because it's easy to get mixed up with decimals. So just be careful. And this is equal to 56. Look back at your question and make sure you answer it. $14 is 25% of what amount of money? $56. 26 is 40% of what number? So again, my base is unknown. Okay, so 26 is my A, is 40%. I know that's just me. 0.4 times B. Same thing again. 26 divided by 0.4 is equal to 65. So 26 is 40% of what number? Actually, it's just asking what the number. 65. 135 is what percent of 27? So now what's missing? My percent, right? What percent? My percent is missing. So I need to know my P, and then from there I need to convert it back to a percent, right? Because P is usually a decimal. So 135 is what percent of 27? This of, that tells me that this is my base. 135 becomes my A, and I'm trying to find my P. Okay, so we have A equals P times B, so I have 135 equals P times 27. I'll divide by 27. From there, P is equal to 5. And right now, this is in decimal form, right? So whenever doing this, we're working with it in decimal form. So be careful because you'll have to convert it back to percent. So we're going to actually give us 500% because the equivalent to 5 is 500%. Okay, so we'll move it back 2 times to the right, the decimal. 48 is what percent of 160? Again, we're going to have to find P and then convert it to a percentage. So we know that of 160, this is my B. This becomes my A. So 48 is equal to unknown, right? We have our variable times 160. I'll divide by 160 to solve for P. 48 divided by 160 using a calculator is 0.3 is equal to P. I want to convert to percent. So this, I'm going to move it 2 times to the right. 1, 2. That's going to be 30%. Moving on now to an example of modeling. So we're going to look how we use it in real life, even though all those were really actually applicable. There are about 170,000 species of butterflies and moths in the world. Butterflies and moths themselves make up about 17% of all classified insect species. Estimate how many insect species have been classified. So again, we're going to look at our part over a whole, okay? So my base is actually going to be how many in total. So we can use what we started with before, where part over whole equals our percent over 100, right? So n over 100. Or we can use what we've been doing, which was A is equal to P times B. So we'll just have to identify which is my percent, which is my number that's being compared to our base. Okay, so my base is going to be how many altogether. This is unknown because we want to estimate how many insect species there are altogether. So that's going to be my unknown. So I'm actually going to put, I'm looking for B, 170,000. That'll be my A, right? That's the number I'm comparing it to. So 140,000 is equal to, my percent is 17. The numerical decimal form of that is going to be 0.17 times my unknown base. We'll solve for b now by dividing by 7.17. This will give us 1 million is equal to b. So we're going to interpret our answer in a sentence. Estimate how many insect species have been classified. You can say about 1 million insect species have been classified. So I'm actually going to show you one other way to do this, which is actually the way that I learned it when I was a student, using the part over whole. Okay, so the same thing again, 170,000 or 17%. So I know 170,000 is some part over part of, it's part of some number, right? So part over whole is equal to n over 100. So it's 17% of some number. So we'll just say that 170,000 over, I'm going to say n, is equal to my percent, 17 over 100. I'm going to solve this by using the cross multiplication property, which we learned before. Is equal to 17 n dividing by 17. I'm left with the same thing, 1 million. So good luck. I hope that this is helpful to you and that maybe now you know a little bit about percents.